Hello, welcome back to the channel. So let's continue our previous video and do one simple question on numerical integration. So in this question, we will do two calculations. One calculation will be calculating the upper bound on the error using Simpson's rule, and the second calculation would be calculating the Simpson's rule approximation of this definite integral over here. So this question will be divided into two videos. In this video, we'll cover this upper bound on the error calculation, and in the next video, we'll talk about finding the Simpson's rule approximation and also calculating the absolute error in the approximation that we will do in part B in this case. So this is the integral over here, and this is a fairly simple integral, right? We already know the answer to this integral, the exact answer to this integral, but we will use approximation methods in order to analyze the answer, the approximated answer to this integral by using the Simpson's rule method, and we'll see how it differs with the original answer that we already know about this integral over here. So in this video, we will be using the concepts that we covered in the last videos, and the one very important concept that we covered in the last videos was calculating the values of m and l in this case. So whenever you want to calculate the upper bound on the error using Simpson's rule, you use this formula over here. This expression will give you the upper bound on the error using Simpson's rule. So if you want to calculate L, L will be a reasonable maximum value of the fourth derivative of x. Indeed, the absolute value of the fourth derivative of x. So if you have not watched my previous videos on calculations of L and M, I'll highly suggest you to first watch those videos in order to get the full idea about this error approximation question over here. So now we know that if we want to calculate the upper bound on the error using Simpson's rule, we have to first calculate L, right? And in order to calculate L, we'll have to calculate the fourth derivative of f of x in this case, right? In this case, our f of x is the function for which we are calculating the integral for. So in this case, since the f of x is cos x, so if f of x is cos x, f dash x is minus sin x, f double dash x is minus cos x, f triple dash x is sin x, and f to the power 4x, the fourth derivative of x is cos x in this case. So now we have the value of the fourth derivative of x. We know that we have to solve this equation over here in order to calculate the L, right? So L would be a value, a reasonable value, which would conclude the maximum value of this function over here, right? And we know that since cos x and sin x are bounded functions, we know that the value of cos x, the maximum value of cos x is 1, right? Cos x always alternate between the values minus 1 and 1, right? So we know that in order to calculate the maximum value of the fourth derivative of f of x in this case, L would simply be 1 over here, right? So 1 would be a reasonable maximum value of cos x in this case, right? So we have calculated L. Now in order to calculate the upper bound on the error using Simpson's rule, we'll have to use this formula. And this formula is basically, we already have the L, b minus a, b is your upper endpoint, a is your lower endpoint, and n is the n which is given in the question. So if you want to calculate the upper bound on the error, which is also denoted by e of n, it would simply be L by 180 b minus a to the power 5 upon n to the power 4. And now we'll plug in all the values that we know. L is 1, so it would be 1 upon 180, b minus a, b is pi, a is minus pi, so b minus a would simply be pi minus minus pi, which would be 2 pi, right? So b minus a is 2 pi to the power 5 upon n is given in the question, n is 4 in this case. So if n is 4, it would be simply 4 to the power 4, and you can simplify this answer or you can leave the answer as it is. So this would be your final answer to the upper bound on the error using Simpson's rule with n equals 4 for this definite integral over here. So that's it for this video. Again, the main takeaway from this video is that whenever you have to calculate the upper bound on the error using Simpson's rule, you always use this formula. And before using this formula, you should know the value of L. In order to calculate the value of capital L, you'll find the maximum value of the fourth derivative of f of x. Indeed, the maximum value of the absolute value of the fourth derivative. Just like we did in this question, since our f of x was cos x, our f of 4x also became cos x, and in order to calculate the maximum value of this fourth derivative, which is cos x, we already knew the maximum value of cos x, which is 1. So that is why we concluded our L to be 1 and then solved the rest of the question. So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.